All
Hi
right.
everyone. Hi
Hi,
everyone.
Rahul. Before
Hi,
we
Rahul.
go forward, I should mention that in addition to our ASL interpretation, we also have captioning available on our LinkedIn live stream. So if that will be of benefit to you, you can see both the ASL and the captioning together if you are on LinkedIn Live. All right, so Rahul, great to see you.
Hi Jeff. Hi Veliswa. I'm really excited to be here at AWS On Air with both of you. And I can't wait to introduce everyone to a new AWS service that we announced just last week, AWS Cloud Control API.
It was so exciting to read about it, and give us a sense of the customer challenges that you were addressing when you decided to build the Cloud Control API.
Oh, absolutely, Jeff. And in fact, before I answer this question, I would like to introduce everyone who is listening in to the user personas that Cloud Control API targets, and then the opportunities and the problems that we sought to solve using Cloud Control API. So in case of this product, there are two types of customers that we have. First are the builders or developers, who are the end users that build application infrastructure, manage them, and monitor them on AWS. And the second are AWS partners or AWS Partner Network APN partners who build on top of AWS and expose their SaaS-based solutions, be it infrastructure as code, configuration management, cloud security posture management to end users. We identified three problem areas or three opportunities to help these customer personas that we just identified earlier. So let me get straight into it, Jeff. First, we heard from builders and developers that use AWS partner solutions to build and manage their cloud infrastructure that they want to accelerate the pace of innovation and time to market for their applications. For example, there are situations these builders face when there's a lag between supporting a new AWS release, some of those which Jenna talked about earlier as well, and in APN partner solutions. Like, for instance, if an Amazon Kendra resource is unsupported in a partner solution, then customers using that tool will need to wait for its support before they can use that resource to analyze and search through unstructured data using machine learning. The open question for us was, can we help these builders and developers adopt new AWS features and services closer to their launch? That was problem number one. The second was specific to AWS partners, right? Like, as we know, while AWS continues to innovate on behalf of its customers to help unlock new capabilities on cloud, we hear from our partners that they want to stay in sync with AWS's pace of innovation, and that it can often take a few weeks of custom development work to integrate with the latest AWS offering and expose them further to their end users. To just give you the scale of innovation, as you're aware, today AWS supports over 200 fully featured services. And in 2020 alone, we launched over 2,700 new significant features. Naturally, our question was, can we support automating the ability for these partners to integrate with AWS? Can we have some sort of unified interface, right, that allows partners to integrate with once and benefit for any new AWS innovation going forward? And last and final was for builders who specifically like using raw APIs or lower level APIs over, like, say, higher level tools. We recognize that we have an opportunity to standardize the APIs that interact with all the AWS features and services. And you may wonder, why was this a need, right? Like, as applications get increasingly more sophisticated, we hear from developers that they need to work across several AWS and, in fact, in some cases, third-party services as well, by using distinct service-specific APIs. While these APIs are descriptive and intuitive, some developers prefer using a more consistent approach to managing these services, right? So that was another opportunity that lay in front of us. And so to summarize, there are these three problems. Can we support new AWS features and services closer to launch? Can we help partners automate their integration with new AWS capabilities? And finally, can we standardize APIs to interact with hundreds of AWS and, in fact, third-party services as well?
All right, so I think you've made a great case for why our customers and our partners could benefit from Cloud Control API. Give us a more detailed sense of what it's all about.
Yeah, absolutely, Jeff. So Cloud Control API can be thought of as essentially a set of common APIs that is designed to make it easy for developers to manage their cloud infrastructure consistently and leverage the latest AWS capabilities faster, typically on the day of launch. So what do we mean by that, right? Like it introduces a consistent APIs to manage the end-to-end lifecycle of AWS resources. Using the APIs exposed, developers can now manage hundreds of AWS resources and over a dozen third-party resources using create, read, update, delete, and list APIs of Cloud Control. At the same time, with this launch, AWS partners can now automate integration with with latest AWS innovation through a one-time integration only, instead of spending weeks of custom development work. As part of this launch, we in fact had two of our partners, Terraform by HashiCorp and Pulumi, integrate their solutions with Cloud Control API to unlock this specific use case.
Okay.
Yeah, and just to summarize, like, right, like the problems that we also identified before, right, like we talked about the consistency of these APIs. At the same time, I do want to point out that faster access to new AWS features and services takes place via Cloud Control API, as it uses the CloudFormation registry to expose the resources built by AWS service teams and third parties that build their solutions. For any new AWS features and services, they're available typically close to the day of launch.
Okay. So you talked about you said you take advantage of the CloudFormation registry, but you also support a subset of what's in the registry. So what is your plan for supporting additional resource types?
Oh, absolutely. Yeah, definitely, Jeff. So resource type support is a key priority area for us as part of Cloud Control API, and we are actively working to support additional resource types, and we plan to add support for specific service resources within Amazon S3 and Amazon EC2 in the coming months. And we would love to like hear feedback from our community of users on what set of resources they would like to see Cloud Control API support. But you bring an important point here as well, Jeff, right? Like, how is this related with CloudFormation registry? And if it is related, why does it support a subset of resources, right? Like, I would love to help our listeners also understand why that's the case, right? Like, let's take the first part of the question, right? Like, how is this related? So, or rather, like, say, what are the differences between the two, right? So, as you can understand, CloudFormation can be thought of as three layers. And when it comes to infrastructure as code service, right? Like you have the resource provider layer as the base layer, which is exposed by the CloudFormation registry. Then you have the orchestration layer for provisioning and other various managed experiences, such as drift detection. And then finally, you have languages associated with configuring resource state using JSON and YAML. Cloud Control API leverages the base layer of CloudFormation and externalizes it for partners and builders to build on top of. And the reason it supports a subset of these resources is because, for the very purpose that we highlighted in the start, consistency and uniformity in terms of in terms of like using a set of standardized APIs to perform create, read, update, delete, and list operations. So within the CloudFormation registry, resources which are specified as fully mutable and immutable are supported on Cloud Control API. And what we mean by the union of these resources are that they have the required set of read and list handlers and permissions that align with the expected behavior we have outlined as part of our resource support contract test. For the remaining subset of resources which are not part of this, we are actually actively working to get them supported in this model as well, so that our builders and partners can enjoy using all the resources, either new or existing, on Cloud Control API.
Got it. Okay. Well, I just heard that Valiswa is having some internet issues, and I'm going to do my absolute best to carry on without her pushing half the buttons. So I will be pushing all the buttons for a little bit. So give me a sense of you talked about how we're supporting AWS resources. How does this actually help our partners?
Yeah, so for our partners, there are use cases, right? Like there are various use cases that I would love to discuss here, and even like for builders. Specific to partners depends upon the kind of tool they have. For example, for infrastructure as code partners like HashiCorp, Terraform, and Pulumi that integrated with us, these partners can now expose the latest AWS services and features in the form of resources to the end customer, so that the time to market and the pace of innovation for our mutual customers is fast, right? Like as soon as new resources are released, they can start using and get building, right? That's for infrastructure as code. And in fact, as part of this integration, both Terraform and Pulumi have released a new AWS provider altogether in preview. It's called the Terraform AWS Cloud Control Provider and the Pulumi AWS Native Provider. Now, but that's for infrastructure as code partners only. The use cases are limitless. Like I'll give you another example of configuration management and cloud security posture management partners, right? They can use the read calls and the list calls and I'm going to show that in the demo as well, of Cloud Control API to read resource level configurations and identify any misconfigurations that takes place on behalf of customers and immediately notify them, right? And they benefit from faster AWS coverage. At the same time, they benefit from using the read list calls in a programmatic manner to expose. And that's for partners, Jeff. And we are happy to talk to you more about use cases for builders as well, who use these raw APIs.
Sure. Give me a sense of how builders can use the APIs, and then I'm actually super eager to see the demo.
Oh, perfect. Absolutely, Jeff. So yeah, for builders, in fact, a part of this I'm going to show in my demo as well. So I'm going to keep the suspense on. But for builders, the first example and one of the most common use cases we hear is identifying and cleaning up resources that are not actively managed. What we mean by that, in fact, one of our customers, Steady, which is also noted in our AWS news blog, authored by our colleague Sebastian Stormack, wanted a programmatic way to list and delete resources, right? Like which were managed outside of their infrastructure as code tool. The challenge today was that because of service-specific APIs, it was challenging for Steady to do this in a scalable and in a programmatic manner. With Cloud Control API, teams or builders can now use the list call to identify these legacy or not actively managed resources, cross-reference them against actively managed resources, and delete those altogether. By deleting these unused or non-active resources, they can help manage their costs better in a simpler and faster manner. And it allows these builders to remove the need to author and maintain custom code to discover and delete, helping improve developer velocity. Similarly, we also have builders in companies that manage AWS infrastructure on behalf of their clients. Many have developed solutions to list and describe resources deployed in their clients' AWS accounts for management and billing purposes. Now, with these list and describe calls of Cloud Control API, they have a programmatic way to do so. So yeah, these are some other use cases that are available for builders to use, and there are more use cases that we are discovering as well.
Awesome. Veliswa, welcome back. And let's jump right into the demo. I'm eager to see this.
Yeah.
Perfect. Yeah, in this demo, I'm actually going to highlight the consistency of the create, read, update, delete, and list APIs exposed by Cloud Control API, and also outline a common use case, which I just referenced earlier, that is listing and deleting resources outside the management of active tools, right? For the purposes of this demo, I'm going to showcase the consistency by using 3 different AWS resources, AWS CloudWatch log group, Amazon kinesisStream, and Amazon ECS Cluster. But as you see on my screen right now, I'm sharing the resource configuration or the desired state of these resources on my text editor. So let me do a quick walkthrough, and then I'm going to jump right into my demo. In the first screen here, you are seeing my CloudWatch log group desired state. And as you are aware, CloudWatch log group is a group of log streams that share same retention, monitoring, and access control settings. I have specified my configuration with the name of the log group and the retention policy, which specifies 90 days in my configuration to retain log events in a specified log group. I also have a few other configuration files. This is a patch document, which I'm going to demo, wherein you will see I'm going to update the value of retention days of CloudWatch log group from 90 to 10 years, 90 days to 10 years, which is 365, 3 days. For kinesisStream, similarly, I am going to specify the configuration. In this case, Amazon kinesisStream captures and transports data records that are continuously emitted. So I'm going to specify the name of the Kinesis stream, the shard count associated with it, and again, the retention period, that is the length of time data records are accessible. In this case, 168 hours or 7 days. And I'm going to add tags to this Kinesis stream when I update the resource. And finally, I'm going to also showcase the consistency via an ECS cluster example where I'm going to specify cluster name, tags, and cluster settings. So without much ado, let's get straight into the demo. I'm going to switch over to my terminal. This is essentially my active working directory. I have all these desired state file JSON available. I'm going to clear this right away, and I am going to start with creating a CloudWatch log group. To do that, I am going to specify Cloud Control API's create resource call, specify the resource type name, in this case is the CloudWatch log group, and the state file path. In this case, it's in my working directory, so I specify that. As soon as I do that, it's an asynchronous call. You see a progress event return, which outlines that this particular action is in progress. And I can easily check whether this was successfully created or not by taking the request token and passing it here. You notice, bingo, the create is successful. So my CloudWatch group is created. And now I can actually, in my account and in this region, I can list the CloudWatch log group by using Cloud Control's list resources call, where I specify the type name and I see the output. I see that identifier my demo logs, which was created with all the properties I specified, retention days, and it returns the Amazon resource name as well. Now, as you had seen in my patch document, I was changing the resource, the retention period from 90 days to 10 years, 3653 days. So I'm going to use the update resource API call, specify the update resource, pass in the type name and identifier, and pass in the path for the patch document. And you see that this operation is in progress, and you see the resource model get updated with the retention days of 3653. And now, specifically for the use cases of reading the state of the resource, either for partners or builders, all I need to do is pass in the get resource or the read call, pass in the type name and the identifier, and get the output, right? You would essentially get all the details associated here. And I can similarly delete, I can have the demo logs deleted as well by using the delete resource API call of logs group. And it's an asynchronous call. It will show in progress, but a simple way to just check whether this is existing or not is by calling list resources. And now you would see a null value, which means this resource is deleted. Now, why did I do this? I wanted to showcase the create, read, update, delete list flows. And now I'm going to do the same thing for Amazon kinesisStream and ECS Cluster. And I'm going to go through very quickly to show the consistency. So let's go ahead with creating the Amazon kinesisStream resource. Again, just the same API call as I want to do highlight to the users. You don't have to use separate API calls by service. You use the same create resource call, the same input parameters of API, pass in the file, and you get a similar response value out, right? So that's one of the powers of Cloud Control API. Now, to see whether this resource was successfully created or not, I can use the get resource request status, which is an auxiliary API available by Cloud Control API, and I can pass in this request token, so just the way I did for CloudWatch log group. And let's see whether this was successfully created or not. And yes, bingo, again, successfully created. The state file that I highlighted had the right configuration for kinesisStream. And now I can actually list these resources, this specific resource, by calling the list resources call, pass the kinesisStream resource type, and see the output. You see the identifier, my demo stream, which I highlighted here, gets output, right? Now I'm going to make an important step here. I'm going to use the update API call to add tags to my kinesisStream resource. Tagging has, as most of you know, benefits of tagging that I'm going to just like outline here. I'm going to use the update resource, same input parameters. And in my patch document that I had, I'm going to just quickly just show the patch document here. I am passing the tags of key, environment, and value dev, and the operation is add because the tag did not exist before. So I am going to do that. And let's see, you see the resource model gets updated. with the tag values, with value equal with key of environment, what environment is it, development, staging, production. I put the dev environment and it gets ready. And I can now read the state of the resource as well. All I need to do is the same get call, pass in the kinesisStream, and get the output. And this time you would see all the details associated with the tags as well. And now I can use a delete call similarly to delete my kinesisStream as well. And while this deletion is in progress, I can either use the auxiliary API to see whether this delete operation was successful or not, or I could just use a list resource call to see whether this resource exists. And in this case, you see it's deleted, it's null value now. And I'm going to just showcase the same for ECS cluster as well. In case of ECS, we essentially pass in, we have the state file already mentioned in my configuration file that I highlighted. Same API calls, same input parameters. You can create the ECS cluster as well. And while this gets created, I'm going to skip a few steps and just show you what becomes our final output, right? Like you see the list resources and you see the value of the ECS cluster, all the properties that I specified gets output along with the Amazon resource name. So I can do the same operation for delete, list, update, create for any of the supported resources by Cloud Control API. There are hundreds of AWS resources supported. And in fact, even third-party resources such as MongoDB, Datadog, Atlassian Ops Genie resources, among others, which are available in CloudFormation registry and exposed by Cloud Control API, and you can do the same. I will conclude the demo by just highlighting one of the use cases which we discussed for builders, which is, can I list or can I identify and delete resources that were not managed by Cloud Control API? They were either created directly from console or the CLI. Can I still discover them? Absolutely, yes, you can. And I'm going to just do the same right away in the demo. I'm going to create a CloudWatch log group, and I'm going to use a service-specific API here. I'm going to use the create log group to create it. Just named it my sample log, and I'm going to put a retention policy associated with it. And my sample log retention day is 90. Now this log is successfully created. And as you see, I created this not using Cloud Control APIs, create APIs. Neither did I use the console. I used the CLI directly and use the raw API calls. I can now discover them using Cloud Control's list call directly. And I'm going to just do that in a second here. I will use the list resources call, specify it here with the type name logs log group. And you would see my sample log would now show up. The identifier shows up with all the required properties. I can discover them. And now I can also discover and delete this as well by passing in the identifier that we had. In that case, I'm going to specify the identifier that I created, which was, and if I recall correctly, it was my sample log, but we'll see if there is any error message that gets exposed if that's not the identifier. And let's see. Oh, this is a get resource call. I'm going to use the delete resources call. I read the state of the resource. I should be using the delete call. I'm going to pass the identifier here, and the deletion is in progress. And now when I use the list resources call, it would result a null value. So with this, you can programmatically discover resources that or take an inventory of resources that were tracked outside of any tools or any tools from wherever it's done. You can use Cloud Control API to identify them and delete them as well, helping with cost management use case at the same time for helping increase the developer velocity. So with this, I'm happy to conclude the demo, and I can't wait to have listeners, builders, developers, and partners start using Cloud Control API.
Wow, that was really, really cool. So a couple of things I really liked about this is it's uniform. I love the fact that you really focused on resources. You barely had to really mention particular service names, and you really said, well, I want this and I want that. And the fact that the desired state model is, to me, so interesting. It just says, this is what I want. And you're effectively just turning control over to the Cloud Control API and saying, I'm not too worried about the details of how to make one of these and get all the properties set up. just make me one, please. And that's I think a wonderful simplification, and lets our customers just focus on the target versus thinking what are the very interesting but lower level mechanics of how to actually make that happen.
I think it's so awesome. I think you also mentioned, Rahul, at the beginning that you can actually use an SDK for this, so you can programmatically integrate and off you go. I think it's awesome. So in the chats, let us know. Do you have any questions for Rahul, and what do you think? I think this is really, really exciting, and I love those demos, Rahul. Thank you so much for that. Jeff, anything else that you'd like to say? This was really, really exciting, and I'm really just looking forward to everything today.
Well, we had one really interesting question. We had a question from someone who was named LinkedIn user, and LinkedIn user asked us, where are the state files stored? Is this in CloudFormation?
Oh no, so these state files can be, these desired state files can be stored locally, right? Or you can even pass these as a JSON blob directly on the CLI while you're passing in. So it need not be stored in CloudFormation, right? Like as I mentioned, what Cloud Control API does is it leverages the resource provider layer or the base layer exposed by CloudFormation registry. And the state files, these desired state files can be stored locally or can be passed in as a JSON blob directly in my CLI.
Excellent.
Great. I see there's a comment there. Thanks for the demo. That was really cool, and I agree. And that was great. So anything else, Rahul, before we let you go?
No, thank you for having me here, Velaswa and Jeff. This was really exciting, and as I mentioned, can't wait to get everyone started using Cloud Control API. Thank you.
We got we got lots of questions in the chat as well for your Twitter and your LinkedIn, where to find you. There's lots of people looking for you. We are sharing a couple of resources in the chats, so just look out for those, and I'm sure somehow there you'll be able to find Rahul. Thank you so much, Rahul, for this.